Good morning, students. Today we are going to start our new unit, your new subject, that is the design and analysis of algorithms. The book you are going to refer for this subject is Introduction to Algorithms by Corman. So let us discuss what is the course is all about. This is actually the study of algorithms. In this subject, you need to design your new algorithms, your own algorithms, and you have to do the study of these algorithms, whether they are good or not that good. So we must take care of these three things. First thing is the algorithm must be correct. It should be the first and mandatory thing is the algorithm must give correct answer, the answer we want to get. Second is it must terminate correctly. And third thing, the main basic of this subject is that the performance of algorithm is needed to be good. That's how an algorithm is said to be a good algorithm. So, design and analysis of algorithm. Let us understand the meaning of the subject name. First is design and another is analysis. First thing is you need to design algorithms that minimize the cost. Analysis means predict the cost of an algorithm in terms of resources and performance. Means you need to design the algorithms and also analyze whether it is a good algorithm in terms of time and resources and the complexity. So let us discuss all this with an example. Let us take an example of sorting. If I tell all the students present in the class to sort an array, everybody will take its own way of sorting. Some students will take merge sort, some will refer quick sort, some will do sorting with insertion sort. So the input will remain same, output will remain same. What does the things that matters a lot, the performance. If the performance is good, then the algorithm will, we can say that algorithm is good and its performance is good, its time complexity is less, it is taking less source of time. Here you can see input sequence, it denotes the array we want to sort. This is output sequence, means we have to change the sequence of the array. On the first position, there must be a smallest number. On the last position, there should be the greatest number. Take an example. This is input array 824936 and the output array is 234689. It means in ascending order we have sorted this array. We have write A1 should be less than equal to A2, A2 should be less than equal to A of n and all that. Why we have written equal to sign? There may be a case when we are having two same numbers. Means on the position of 8 we may be having 2 and 2, we put it in the ascending order. We put 2 over here, we put 2 over here, so it will remain in the sorting sequence. Take it. Now let us understand all these things with an example of insertion sort. We have taken the same array repeatedly, 8, 2, 4, 9, 3, 6. In the process of insertion sort, we know that we assume that the first number is on the place of sorted itself. We assume the first number to be sorted place. We take it, we start from the second number, that is 2, and we will put the second number. We compare it with the first number. If it is less, we swap it to the first position. First position number, that is 8, will come on the second position. An easy way to understand insertion sort is you can compare it with card playing. When we play the card, we assume that the first number is on its sorted place. We start from the second number, compare it with the first number. If it is less, we swap it to the first position. We take the next number and find the correct position for the number. Here you can see that we have swapped 2 to the first position. Next comes to be the 4. 4 we compare with 8 and we swap it to the next position. Next number is 9. We compare it with the 8. It is already on its correct position. No need of swapping. Next comes to be 3. 3 we compare with 9. It is a smaller number. We compare it with 8. It is still smaller. We compare it with 4. It is still smaller. Even we compare it with 2. We find that the correct position is in between 2 and 4. We swap it to the second position. Last number is 6. And we take this number, compare it with 9. It is smaller. We compare it with 8. It is still smaller. We compare it with 4 and find that the correct position for 6 is in between 4 and 8. Now, this is the pseudocode for insertion sort. We have written the name of the algorithm in capital insertion sort. A and N. A stands for the array we want to sort. N is the number of elements present in the array. We start from J to N. We have started for loop. Previously, I also told you that the first number is assumed to be on its sorted position. So we have started the loop from second number that is 2. We have started the J, a loop, for loop from 2 to N, means from here to position, sixth position, do. Next we have put a do, and this key indicates a variable. In this temporary variable, we have put the value of A and J. A and J means 2. Now, as we all know that we want to find the correct position for 2, so we have put this A of J, it means 2, in the variable, in the temporary variable key. Now we compare this with the first number. First number is, we have taken another variable I and put the value j minus 1, means the first value in I. Now we are going to compare with the first number with the second number. Before we compare, we have put a loop so that we can compare all the elements one by one. While I is greater than, we have put while loop, and I is greater than 0, means we need to compare all the elements till we reach to the position 0. Here we are comparing A of I. A of I means 2 of, it means 2. A of I means array of 1. Here J was 2 and I was 1. And A of 1 is 8. We have compared 8. 8 is greater than key. Key means 2. We have 8. Here it indicates that 8 is greater than 2. As 8 is greater than 2, it means the lower number is behind the greater number and we need to swap it. So in this way, we have swapped it at the position A of I. We have swapped 2. We have swapped 2. We have put this 2 over the first position. Then we make I assigns to I minus 1, means we have further lower the value of I to 1. And here key is, we have assigned key. Key contains the value 2. Everyone knows, and this key we have put in this position. It means we have taken this to this position and taken 8 to the position of 2. In this way, we will complete all the elements. We keep on swapping the elements and we get sorted array. Now, let us compare the running time. Let us understand what is the running time. Running time means how much the time is taken by an algorithm to run and complete all the iterations. Running time depends on the number of elements in the input. As in this algorithm, we have taken 6 elements. If the number of elements gradually increase to suppose 100, the time will also be increased. The running time also depends upon the how much the input sequence is already sorted. If we take an already sorted sequence in comparison to the a reverse sorted sequence, it will take time longer than sorted sequence. Generally, we seek upper bounds means generally we take upper bound means we work on the worst case performance of the algorithm. We generally takes that the sequence is not sorted, or means or we take that the sequence is reverse sorted. Such type of algorithm, such type of complexity is taken under consideration. Kind of analysis, as I told you, worst case performance is usually taken for the comparison. Average case performance means the array is half sorted, and best case means the array is already sorted, and so obviously it will take very less time, so we cannot take this as a performance criteria. So worst case performance is usually taken as the criteria to compare the algorithms. So this was all about the algorithms and insertion sort algorithm and the analysis of insertion sort and the analysis of algorithms. Thank you very much.